Gravity applies to everything. No matter how adapted an animal is to the sky, biology demands that it eventually return to the earth to rest, eat, or simply survive. But the common swift breaks that rule. At a glance, this small brown bird doesn't look like a biological anomaly, but its behavior forced scientists to rewrite their understanding of avian survival. To accurately map their migration routes, researchers fitted a group of wild swifts with specialized, lightweight micro-trackers that logged their movements day and night. This chart plots 10 months of altitude data. A continuous line tracks the bird's height, missing entirely any dip to the zero baseline. Zooming into any 30-day window, the result is identical. For 10 months, they never touched the ground. By remaining airborne for nearly a year, the common swift logged the longest continuous flight ever recorded in the history of biological observation, which leaves a massive mechanical problem. A living organism requires fuel and rest to survive. How does a bird eat? How does it drink? And how does it sleep suspended miles above the earth? Every basic need typically solved on land had to be adapted for an entirely atmospheric environment. Take nutrition. The swift acts as an aerial predator, flying with its beak wide open to harvest what scientists call aerial plankton, clouds of small insects drifting on high-altitude wind currents. Drinking requires a high-stakes precision maneuver. The bird glides down at high speed and gently skims the surface of a river or lake, scooping up water without breaking its flight path. They even handle complex social interactions entirely in flight, including mating midair. By moving the entirety of its life cycle into the clouds, the swift has completely severed its reliance on the resources of the ground below. But the most difficult biological barrier to non-stop flight is sleep. A brain requires periods of system recovery. To solve this, the bird climbs to extreme altitudes, sometimes miles above the surface, and then begins a slow, controlled glide downward. This long descent creates a window of time for rest. Here is the bird's neurological solution: unihemispheric slow-wave sleep. Instead of shutting down entirely, the swift powers down one half of its brain at a time. The active hemisphere handles essential motor functions, forming a biological autopilot loop that keeps the wings stable while gliding. This rotating system gives the swift deep, restorative rest without ever needing to find a branch to perch on. That internal autopilot is the precise mechanism that allows them to inhabit the atmosphere as a permanent year-round home. In biology, extreme specialization often requires a significant trade-off. To gain an overwhelming advantage in one environment, an organism sacrifices its capability in another. For the common swift, total mastery of the air comes at the cost of its terrestrial mobility. Over generations of relying solely on flight, its legs and feet have become severely underdeveloped. They are practically useless for walking or hopping on a flat surface. This creates a physical trap. Because the bird's legs are so short and its wings are incredibly long, it lacks the leverage to push off the ground and generate the vertical lift needed for takeoff. For an animal that routinely survives 10 months of continuous flight, making contact with a flat patch of dirt is a terminal event. Once grounded, it simply cannot launch back into the air. The common swift achieved total dominance of the sky by entirely surrendering its ability to survive on the earth.